Good morning, Algebra I Honors. Let us begin this morning with a prayer. En nombre del Padre, del Hijo, del Espíritu Santo. Amén. Dios te salve María, llena eres de gracia. El Señor es contigo. Bendita tú eres entre todas las mujeres y bendito es el fruto de tu vientre Jesús. Santa María, Madre de Dios, ruega por nosotros pecadores, ahora y en la hora de nuestra muerte. Amén. En nombre del Padre, del Hijo, del Espíritu Santo. Amén. Hope everyone had a great weekend and a beautiful Mother's Day weekend with your moms. Okay, we're going to continue with our radicals. One thing I wanted to make sure, and I saw in a lot of your homeworks as I was reviewing them, some of you are giving me the answer, but you're not checking to make sure that your final answer is simplified or not. So let's say we have a final answer and you get 2 times radical 12. Well, I'll give you credit for that, but I'm going to put not simplified. Because see, I can simplify 12 into 2 times the square root of 4 times the square root of 3. So you've got to look and see if the factor, the radicand that's left under the radical symbol, that's what it's called, the radicand, if that has any perfect squares. And since it does, I'm going to have a 2 times a 2 times radical 3, which is 4 radical 3. A lot of you are leaving this as it was, so you've got to check your radicands, especially this week when we're doing some more of these, all right? So check to make sure you simplify your radicals. All right, so today what we're going to do is we are going to look at some problems where it's a little bit different, where we get a little bit of a different problem or an answer. So for example, if I said, I'd like for you to simplify this. 3 divided by radical 5. Well, we have an issue. And one of the main issues in algebra is we can never have a radical in the denominator. We got to get rid of it. We can't have it. Okay? And in order to do this, what's called rationalizing the denominator. We want to make it so there's a whole number there, no radical. So, in other words, and a way to do that is, watch how easy it is. We're going to multiply numerator and denominator by the same number. What same number? Well, if you remember, in order to get a whole number here, I would have to multiply this by some term that would make it a perfect square. So if I multiply it by itself, radical 5, and I multiply the numerator by radical 5, this is what I get. I get 3 times radical 5 over radical 25. And go, oh, what's the square root of 25? 5. So 3 square roots of 5 over 5. I've simplified that. I've rationalized it because I can't leave a radical in the denominator. Now you might say, Mr. R, can I simplify the 5 and the radical 5? No. Remember, one is a whole number and one is a radical, so you cannot simplify that. All right? So let's try another problem. How about this one? Radical 7/8. Okay, we can rewrite this if we want to make it a little bit easier. Radical 7 over radical 8. All right. In order to rationalize, we can't leave the radical 8. What are we going to do? Multiply numerator and denominator by radical 8. So we have radical 56 over, you know that's going to give you radical 64 or 8. Now, you might say, well, I see a little pattern. True, because remember, this and this mean the same. They mean this. The square root of 8, quantity squared. Remember, these are opposites of each other, and that's where you have the 8. Now you have to look and see if 56 has, all right, any perfect squares in there, all right, that we could possibly work with. Well, look at your factors. There's a 2 times what in this case? 2, 16, 8, 2 times 28 will give us 56. What about 3? 3 won't, all right? How about 4? 4 is 1, all right? And it'll be 56, 16, 14, all right? We're getting there, all right? 5, 6, 7. You get 7 times 8, all right? What we're going to do here is we're going to see if we can get a perfect square, all right? And see if we can simplify that any further on that problem, all right? Now, in this case, we're going to use 4 and 14 because 4 is a perfect square. So I'm going to rewrite this as radical 4 times radical 14 over 8. All right? Can't leave it like this because it has a perfect square. 14. None of the others work. We're going to simplify that, and that's going to give us 2 radical 14 over 8. Now your question might be, can I simplify these? I couldn't here, but can I simplify these? Yes, because they're out of the radical. So that's 1, that's 4. My answer is radical 14 over 4. Now, let's look at this problem one more time, because we worked very hard here. I want to show you how you might be able to simplify your work. So let's start from here. Let's rewrite it. Radical 7 over radical 8. How about if we simplify? Notice when we multiplied by 8, it gave us a larger number to work with. What if I simplified this to radical 7 times radical 4 times radical 2? Okay, so what do I get? I get radical 7 over 2 times radical 2. Uh-oh, but I still have a radical in the denominator. Okay, no problem. I can go ahead and do what I did up here. Multiply times radical 2. Now some of you are looking at me and go, whoa, Mr. R, there's that 2 there. Don't worry about the 2. You're going to carry that 2 on with you. Because if you multiply times 2 radical 2, you could multiply times 2 radical 2. It just makes your numbers larger, and then you have to go simplify. So therefore, let's just leave it that way. Okay, no problem. I can get this. I get radical 14 over, bring the 2 over, don't forget, and radical 2 times radical 2 is radical 4, which is 2. All right? So now, we can simplify here. All right? So you get radical 14 over 4. All right? Same thing. You decide how you'd like to work that out. All right? Now, here's another one that I'd like to show you. How about this problem? If we had something like this. Nine radical 3 over 24. Okay, well, we can't leave this. You can multiply numerator and denominator by rationalizing by radical 24, but we just talked about that and we said, don't want to do that. So let's rename that. We can say 9 times the square root of 3 over radical 4 times radical 6. Perfect square. Okay, so now I can say 9 radical 3 over 2 radical 6. Okay, I can work with that. Now, I still have to get rid of this radical. So it's a lot easier multiplying by radical 6 than radical 24. Big numbers, more simplifying and more factors you have to find. So this becomes 9 radical 18 over, this is 2 times, you know that radical 6 times radical 6, radical 36, or 6. So I'm going to put it down here. Now we have 9 radical 18 over 12. Can we simplify these two? Sure, by 3. So we'll get 3 radical 18 over 4. Now some of you would stop there and say, I'm finished. You got to stop and look. Remember what I just talked about with 12. 18, does 18 have a perfect square? It sure does. I'm going to move over here so I don't get out of your screen. So let's take this one, 3 radical 18 over 4, and say, hey, I can rewrite that as 3 times radical 9 times radical 2 over 4. This radical 9 is 3. 3 times 3 is 9 radical 2 over 4. Can I simplify any further? No, I'm finished. All right? A little extensive, I should say, in solving this. But let's look at something else. So you always have to show you, these are the steps. Let's look at this problem in another way, now that you've seen it. I'm going to move it over. 9 radical 3 over 24. Some of you might have seen, hey, Can I simplify these? You can if you put them under one radical. So just be careful with the 9. That's like 9 over 1. So I'm going to put it as 9 over 1 times, and now I can do this. Radical 3 over 24, which gives us 9 over 1 times, we simplify this in here, be 1/8. So you have radical 1 over radical 8. Now, a lot easier. I don't have to worry about these numbers. I don't have to simplify this. I've already simplified it. And now, okay, so in the numerator, radical 1 is 1. So I'm going to get 9 in the numerator over radical 8. But you know what? I can break down radical 8 into what? Radical 4 times radical 2, which gives me, that's going to be a 2, 9 over 2 radical 2, rationalized by multiplying by radical 2. All right, so I'm going to come over here now. So we have 9 radical 2 over, okay, you have the 2. 2 times radical 2 times radical 2 is radical 4, 2, which becomes 4. And here's the answer we had. Maybe a little bit easier in simplifying things, all right, that you saw. So we can simplify these in a very variable of ways. So it varies how you do it, whether you want to work smart or hard. I will always say, work smart. Try to simplify. We did the one time. But if you can simplify, you can put these under one radical and simplify. Okay? All right. We did talk about multiplying. You're going to have some more multiplications today. So if I gave you something like this, 2 radical 3x quantity squared. All right? So that means this. 2 radical 3x times 2 radical 3x. Okay? So 2 times 2, 4. Times radical, 3 times 3, 9. X times x, x squared. All right, so we're going to get 4 times square root of 9 is 3. Square root of x squared is x. So we get 12x. Look at this and go, whoa, wait a minute, Mr. R. Can I shorten that a little bit? Yes, you can. Because you're going to square each term. 2 squared, 4. Remember that radical 3x quantity squared, the opposites here, gives you 3x. 4 times 3x is 12x. Okay? So there's a shorter way of doing it, but you've got to be careful how you do this step by step. All right? Let's give you one other one that'll help you in this week's homework. So when we're distributing, let's say we have radical 2 times radical 3x minus radical 5x. All we're going to do here is distribute again. So we'll distribute this. We're going to get radical 6x because they're both under the radical. All right? Minus, in this case, radical 10x. We can't do anything with it. If we had a 2 out here, then we'd have to say our answer is going to be 2 times radical 6x minus 2 times radical 10x. All right? If that was the case. All right? But it's not. All right? So that's a little bit on your Monday through Wednesday assignment. And then we're going to jump over into addition and subtraction of these. We did multiplication. Now it's addition and subtraction of radicals. All right? Addition and subtraction of radicals, not too difficult, just a little bit of math involved. So let me give you this. Let's start off with this. What would your answer be here? 2a plus 3a. I hope you all said 5a. So what would your answer be for this? 2 times the square root of a plus 3 times the square root of a. Your answer should be 5 times the square root of a. So what did you just learn? As long as the radicands are the same, you bring it over as if you were adding terms together. But they have to have the same radicand. So if I have negative 8 radical AB plus 9 radical BA. Do we have the same radicands? By now you should say, yeah, the order doesn't matter. So we're going to take the numerical coefficients here and say, okay, my answer is going to be 1. If you want to put the 1, you can. 1 radical AB. We don't multiply them, we're adding them. So we just carry it over. Make sure that they're to the same power, all right? And then we can simplify if we need to after that. Okay? All right, let's look at another one. It works with numbers, variables. So let's say we have 8 radical 3 minus 7 radical 3. Well, your answer is going to be 1 radical 3 or simply radical 3. It works with that. It works with variables and numbers, all right? What about something like this? 5 radical 3 plus 6 radical 75. So look at that. Now, here, do we have the same radicand? No, we don't. Can we simplify that? No. So we're just going to bring it down. 5 radical 3 plus 6, we can't do anything with it. Can we simplify radical 75? We sure can. Into radical 25 times radical 3. That's going to look good in just a few minutes. Watch. Can't do anything with our 5 radical 3, so I'm going to bring it down. Plus, I can simplify. Square root of 25 is 5. 6 times 5 is 30 times radical 3. Hey, can we add them now or subtract them? In this case, add. Yeah, the radicands are the same. So my answer is going to be 35. We add the 3 and the 5. 35 radical 3. All right? So be very cool. Now, there may come a time, let's say we had this problem, and I'm just going to, you already saw the answer. Let's say we had this problem came down, and then all of a sudden we had radical 2. We just had a radical 2 added there. So what would we do? Well, we had our common terms like we did here. 35 radical 3. We don't add those and get 6, radical 3. Can't do anything with that, so you attach it plus radical 2. You're going to have some of those. That's the term that you cannot combine with the other 2 or the other 3. Just bring it down, and that's your final answer on that. All right? All right. That covers that one. Now, I'm going to give you one more example. These are a little bit tougher. So, what if I gave you this problem? Radical 15 minus radical 3/5. So your first question should be, Mr. Art, you're driving me crazy. Should be actually, I can't subtract these two. This one especially because it has a radical in the denominator. Now you don't see a radical, but it is. This can be rewritten as radical 15 minus the square root of 3 over the square root of 5. Can't do that. So I need to get rid of this. So we're going to have to do some math on the side. All right? Bring this over to the side and let's rationalize it. So we know we're going to rationalize by multiplying times radical 5, which is going to give us radical 15 over 5. Remember, this is the same as the square root of 25, which is 5. Hey, I got rid of it. I just renamed it. That's all we're doing. We're renaming. So this problem now becomes radical 15 minus square root of radical 15 over 5. Now I can subtract them. You might say, how? Well, put this over 1. Subtraction. I have to find a common denominator. Here's where it gets a little tricky, but not really. Watch what happens. Common denominator is easy. It's 5. 5 divided by 1. 5. All right? 5 times radical 15 is going to be 5 radical 15. Since this is not in a radical, this is, you cannot multiply them together. Just 5 times radical 15. Minus 5 divided by 5. 1 times radical 15 is radical 15. Now remember, class, what number is understood in front of this radical? There's a 1. So what's 5 radical 15 minus 1 radical 15? 4 radical 15 over 5. If this was a 10 or a 15 or a 20, I could simplify. But since it isn't, that's it. So what did I do, class? we have a problem where we have a fractional term here. We rewrite it. We rationalize it to get rid of the radical in the denominator. Once we do that, we bring it back to our problem and say, okay, now I can subtract them. And I find a common denominator. Remember, we have to make equivalent fractions. We say 5 divided by 1 is 5, times radical 15 is 5 radical 15, and 5 divided by 5 is 1. 1 times radical 15 is 1 radical 15. And now, since the radicands are the same, I can subtract them. So you're going to have some of these on your assignment. I'm going to do one more to make sure you guys have it, okay? One more and then we're finished. All right, how about this one? Radical 3 minus radical 1/3. Okay? So what's your issue? You should have said is, hey, I got a radical in the denominator. So on the side you can rewrite it like this. Okay? You're going to rationalize by multiplying times radical 3. So my answer is going to be radical 3 over 3. So I've just renamed that. So I have radical 3 and put it over 1, so that way you don't get confused, minus, rewrite it, radical 3 over 3. Common denominator, 3. 3 divided by 1 is 3. 3 times radical 3 is 3 radical 3. Minus 3 divided by 3 is 1. 1 times radical 3 is 1 radical 3. I put the 1 there just so you know. You don't have to put it, as long as you see it. All right? So now, 3 radical 3 minus 1 radical 3 is going to be 2 radical 3 over the denominator of 3. Can I simplify the 2 and the 3? No. That's my final answer. All right, guys? All right. I'll give you your assignment. It'll be twofold on this for Monday and Tuesday, and then Wednesday and Thursday. All right? Have a great week.